Differentiation stationary points. A stationary point on a curve is where the gradient is equal to 0. So if the gradient's 0, what's dy by dx equal to? Well, dy by dx gives the gradient, so it's equal to 0. Or f dash x is equal to 0. So on a curve you can have a maximum point, and right at the top here the gradient is 0, so that's a stationary point. Or you can have a minimum point like this. The gradient right at the bottom here is also 0, so it's a stationary point. A curve can have multiple stationary points. For example, this curve here has 2 stationary points. This curve here has a stationary point in this region here, and there's another one around here. This curve has a stationary point here, here, and here, so there's 3 stationary points here. How many stationary points does this curve have, and what are the x-coordinates of those stationary points? So we know that a stationary point is where the gradient is 0, so let's work out the derivative, dy by dx, which will give us the gradient of the curve. So dy by dx equals 3x squared from the first term there, minus 2x from the second one, and differentiating 3 just gives you 0. And for stationary points, we can say that the derivative is equal to 0. So now if I factorize, so I've got x brackets 3x minus 2 is equal to 0. So that gives x equals 0 from this, and this factor here, 3x minus 2 equals 0. Take the 2 over, divide by 3, x is equal to 2/3. So this has shown that this curve has 2 stationary points, and these are the x-coordinates for those stationary points. Let's say that you also need the y-coordinates for the stationary points. So we've got the x-coordinates here. If we substitute in the x-coordinates into the equation of the curve, so putting 0 in will give us 3. So 0, 3, these are the coordinates for one of the stationary points. And doing the same here, if you substitute in x equals 2/3 into the equation of the curve, then y is equal to 2/3 cubed minus 2/3 squared plus 3. And cubing this, well, that's not easy to deal with. Let's write everything as a fraction with a denominator of 27. So 8 over 27 minus, if I multiply the top and the bottom by 3, 3 4s are 12, 9 3s are 27, plus 81 over 27, because 81 divided by 27 is 3. And then simplifying that gives 77 over 27, so we have our coordinates for the stationary points. Now this curve has an x cubed term that has a positive coefficient, which means the curve is like this in shape. So the 2 points that we've worked out are here and here. These are the 2 stationary points. These are the coordinates for the stationary points, so this is a maximum point and this is a minimum point. Now once you've worked out the coordinates for the stationary points, typically you have to state whether the points are maximum points or minimum points. And there is an alternative method to what I've shown you here to work out or to show whether something's a maximum or a minimum point, and it involves differentiating twice or working out the second derivative. The second derivative is written like this: d2y by dx squared, or in function notation, that's not f to the power of 11, it's f double dash x. To get some practice on working out second derivatives, starting with the equation of a curve here, y equals x cubed, so dy by dx is 3x squared. So the second derivative means just differentiate once more, so that 2 times the 3 gives you 6, x to the power of 1. So dy by dx is equal to 5x to the power of 4 plus, this is x to the power of 1, so the 1 comes to the front, and then you've got x to the power of 1 minus 1 there. If you subtract 1 from the power, gives you 0. You know that anything to the power of 0 is 1, so this is just all 1. And differentiating the second time, d2y by dx squared is equal to 20x cubed. Using the function notation here, so f dash x is equal to, differentiating a constant gives you nothing. That 2 times the minus 3 gives you minus 6, x to the power of 1. And then this is the second derivative now, which gives you minus 6. In this example, the first derivative has already been worked out, so if we just differentiate once more, we'll get the second derivative, minus 10x. Is the stationary point, once you've worked out the coordinates for the stationary point, is it a maximum or is it a minimum point? Okay, so this was the first step. You work out dy by dx, make it equal to 0, you solve that to get the x coordinates for the stationary points, and work out your second derivative, and then you substitute the x values for the stationary points into the second derivative. Okay, you're not making the second derivative equal to anything. What you're doing is you're substituting x values into it. So one of 3 things will happen at this stage. So you've put your x values for your stationary points, you substitute them into the second derivative, and you'll get a value, a numerical value at this point. If it's a positive value, it means your stationary point is a minimum point. And if it's a negative value, it means your stationary point is a maximum point. And if it's equal to 0, the method's failed, so you need to use another method. Now I've come back to my previous example, and just from the sketch of the curve, I know where the maximum and minimum points are. Now I'm going to show that this is a maximum, this is a minimum, without using the sketch of the curve. So these are the 3 steps that I need to follow. The first one I've already done, and the results are as follows. So there's 2 stationary points at these x values. Now I'm going to work out the second derivative. d2y by dx squared is equal to, so differentiating this again, that 2 times the 3, 6x. Differentiating this gives you just minus 2. And now I'm going to substitute the x values into the second derivative. So when x is equal to 0, the second derivative is 6 times 0 minus 2, which gives minus 2. It's a negative value, so it's a maximum point. When x is equal to 2/3, substituting that into the second derivative. 6 times 2 is 12. 12 divided by 3 is 4. 4 minus 2 gives 2. That's a positive value, which means this is a minimum point. So x is 0 is a maximum, and x is 2/3 is a minimum. That's exactly what I had from the sketch of this curve. Okay, so you need to memorize these 3 points here for the second derivative as to whether you have a minimum, maximum point, or whether the method's failed and you have to use something else.